So today we're going to do some review of fraction and decimal computation and the rules for computing with fractions and decimals. This is important because we're going to be dealing with equations that have fractions and decimals within them, and we want to be able to fluently add and subtract, multiply and divide so that we can solve equations. So let's start with fraction addition and subtraction. So if you remember, the idea on fraction addition and subtraction is that you need to have a common denominator. The parts must be the same size. So 7/8 and 4/5, we have two different denominators. We need them to be the same denominator. So we need equivalent fractions that will have the same denominator. Now, in this case, you would think about the multiples of 8, the multiples of 5, and which is the first one that they have in common, and that would be 40. And you could also think about that because 8 times 5 is 40. So 40 is the least common denominator or the least common multiple. You could also use 80 if you wanted to, but then you're dealing with larger quantities, and it might be easier to stick with the smaller quantities. So if we're going to turn 7/8 into 40ths, we did that by multiplying 8 times 5 to get 40. That means we would also need to multiply 7 times 5 for the numerator, okay? Because whatever you multiply the numerator by, the denominator by, they have to be the same to get an equivalent fraction. So do the same thing with 4/5, but this time we're going to multiply by 8/8. Because 8 times 5 is 40, and then 4 times 8 is 32. And now we're going to just add the numerators because 40ths is the part size, and that's like the unit of measure. It doesn't change. 35 plus 32 then is 67, 67 40ths. Now, we are at a point in your mathematical lives that we are okay with improper fractions. We do not have to turn that into a mixed number. Okay, so let's do 3/4 minus 4/5. Again, we have different denominators. We want them to be the same. And if you think about your multiples of 4, your multiples of 5, the first one they have in common is 20. So we're going to turn this into a problem involving 20ths. So in order for 3/4 to be converted to 20ths, we have to multiply it by 5/5. And that would give us 15 20ths. And to turn 4/5 into 20ths, we have to multiply it by 4/4, which would give us 16 20ths. So now the problem we need to solve is 15 20ths minus 16 20ths. And again, 20ths is the part size or the unit of measure, so it doesn't change. 15 minus 16 is -1, so we have -1 20th. All right, so let's try this mixed number problem. Now with mixed numbers, again, you just add the fractions, you add the whole number, and you may have to regroup if the fraction is greater than 1. So first thing we need, I like to stack these, so I'm gonna write it this way instead. If we have halves and eighths, and you think about the first common multiple between 2 and 8, you would get eighths. So we could rewrite 1/2 by multiplying it by 4/4 to get 4/8. 1/2 is equivalent to 4/8. So now we have 4/8 plus 5/8, which is 9/8. 1 plus 3 is 4, but we don't want to keep an improper fraction inside of a mixed number. An improper fraction on its own is fine, but if it's part of a mixed number, then you need to regroup that. You need to restate 9/8. 9/8 is the same as 1 1/8. Combined with the 4 would give us 5 1/8. That is a better way to say that result. Okay, so now let's think about subtraction. Subtraction sometimes involves regrouping. So here the problem is 3 minus 1 3/4. Now you may be able to figure this out, but let's just think about the process for doing that. We don't have any fraction here to take 3/4 away from, but we need some fourths. So we're going to take one of our whole numbers and create more fourths. And you get 4/4 out of a whole, and we didn't have any here. So now we have 4/4 minus 3/4. And before we get to that, 2 4/4 is the same as 3 because it's 2 and 1, right? 2 and 1 is equal to 3. So now we can subtract the fourths, we can subtract the whole number, and we get our difference. Okay, so now when we multiply, it's really not as much about multiplying as it is about simplifying. And we really did work on this already this year when we were working with integer exponents. So before you start multiplying, you want to look for opportunities to simplify. And this is super important going into algebra, that you are identifying those opportunities. So right away, I can see that with any numerator and any denominator, if there is a common factor, that you can simplify those terms by that common factor. So 7 and 8 don't have a common factor other than 1, but 3 and 9 do. 3 and 9 both have a common factor of 3. So we could divide each of those by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And so now we can just multiply the numerators and multiply the denominators, and we will get a result that's already in its simplest form. And so that keeps us from having to simplify it after we've multiplied. So let's look at this multiplication with mixed numbers. Now, whenever you have mixed numbers, you just turn them into fractions and apply the same logic as you did with fractions. So 1 2/5, to convert this to a fraction, I would think about 1 as 5/5. 5/5 and 2/5 is 7/5. And we're going to multiply that times 3 and 3/4. 3, if you thought about it in terms of fourths, would be 12/4, plus 3 more would be 15/4. So we have an equivalent multiplication problem just written in fraction form versus mixed number form. And so now we're going to look for those opportunities to simplify. 7 and 4 don't have a common factor other than 1, so they're already simplest form, but 15 and 5 could be divided by 5 each. And so now we have a simple problem. 7 times 3 is 21. 1 times 4 is 4. And again, when we get to algebra, we leave results of our computation in fraction form, regardless of whether it's a mixed, an improper fraction or a proper fraction. So now let's think about fraction division. Of all the operations, this one tends to give people the most difficulty, but really, if you think about it logically, it can make sense. So if you look here, we have 3/4 divided by 1/4. Now, before you start applying any rules or algorithms, let's just think about this. What does 3/4 divided by 1/4 mean? It means how many times does 1/4 go into 3/4? Well, isn't it 3? Right? Because 3 times 1/4 gives you 3/4. Now, what did we just do? This is a case where you have a common denominator and all you have to do is divide the numerators. Now, that doesn't always present itself as an opportunity, but it can. All right, so then the other rule that you did learn is that you can convert a division of a fraction problem into a multiplication problem. And the way you do that is that you multiply by the reciprocal. And the reciprocal is when you reverse the numerator and denominator. So this would reverse to a multiplication problem that looks like this. Okay, now, again, looking for opportunities to simplify, we have 4 and 4. Which if you divide 4 by 4, you get 1, 1, and then you multiply the numerators, you get 3, the denominators, you get 1, so you get the same result as 3. So there's 2 strategies at work here. One, you can do common denominators, where you only then divide the numerator, or you can change a division problem into a multiplication problem and multiply by the reciprocal. So 2 strategies that you can employ. So let's do this problem both ways that we just talked about. So first of all, I want to make common denominators. So if we had tenths and fifths, I see that I could make this 3/5 equivalent to tenths by doubling and doubling. So now we have 9/10 divided by 6/10, which I can ignore the denominator now because all we're going to do is divide the numerator. 9 divided by 6 is 9/6. 9/6 in fraction form could be read as 9 divided by 6, and then this would need to be simplified to 3/2. Okay, now what if we changed it to a multiplication problem? Well, we would multiply by the reciprocal of 3/5, which would be 5/3. And now we have some opportunity to simplify before we multiply, right? 9 and 3 have a common factor of 3. 9 divided by 3, 3 divided by 3. 5 and 10 have a common factor of 5. And when we multiply, we get 3 halves. So you get to decide which method you prefer. All right, so let's move on to decimals. We did some of this while we were working on scientific notation, so hopefully this can be just a quick review for you. You know that when you add and subtract decimal numbers, you do so by place. So you have to line it up. So this 5 and 7/10 needs to be lined up so that the 5 lines up with the ones, the 7 lines up with the tenths. So now we're just going to add and subtract by place, okay? All right, so let's look at multiplication then. Multiplication is really just thinking about place value again. You multiply the digits and then you consider the place value. So really what we're multiplying in this case is 23 times 5. So I could do the 23 times 5 just using the standard algorithm, okay? But now I need to think about the decimal. And so in this problem, we had tenths here and tenths here. 1 decimal place and 1 decimal place, you add them together to get 2 decimal places. So now we need to count over and place the decimal so we have 2 decimal places. That's all there is to it. Okay, so for division, I just want you to think about patterns, all right? 10 divided by 2 is equal to 5. I think we can all agree on that, okay? What if we multiplied each of the components of this division problem by 10? It would be 100 divided by 20, which is 5. Same result, right? Increasing by powers of 10 didn't affect the quotient, right? If we do the same thing again, if we take 100 divided by 20 and multiply each of these by another power of 10, we would have 1,000 divided by 200, which is still 5, okay? Now we can do the same thing by multiplying by negative powers of 10. Negative powers of 10 then are going to go the other direction on a place value chart. If it's like dividing by a power of 10. If you divided 10 by 10, you would get 1. And if you divided 2 by 10, you get 2 tenths. Well, what do you think 1 divided by 2 tenths would be? Well, it's going to be 5 also, right? Whenever you have, if you remember the parts of a division problem, this is the dividend, this is the divisor. You could also think of it as a numerator and denominator, right? Because there's fractions and division really represent the same thing, just 2 different ways of dealing with it. So if you take any dividend and any divisor and multiply or divide them by the same power of 10, you will get the same quotient. And so that's how we're going to solve division problems with decimals. All right, so look at this division problem. Kind of nasty. And so really what I want to do is get rid of the decimal in the divisor. I just can't deal with that. So we can do that by using that whole power of 10 idea. So what would it take to make 3/10 a whole number? We would need to shift it one place, right? And when you shift one place, you're multiplying by a power of 10. That means we would do the same thing to the dividend. We would multiply this by 1 power of 10, and so all the digits would shift over, and now we have a division problem that's fairly simple to do. So let's do it. 3 goes into 13 4 times, and 3 goes into 15 5 times, and 3 goes into 6 2 times. So we can do division with decimals by shifting or multiplying by powers of 10 to make the problem easier to solve. Okay, so I want to see how you can do on an assortment of problems. So they come from 5 different pages, but there's just really 3 problems per page except for that last one that has 6. So if you write this down, and I would like to see your work on Google Classroom. I do not want to see just an answer. You need to show me how you came up with each answer, okay? Thank you, and I'll see you later.